Every person who has ever lived has seen the same face of the moon. Its other side stayed hidden from all of human history, until, within living memory, a spacecraft finally flew round the back and looked. The easy explanation is that the moon just doesn't turn, that it hangs there with one face fixed towards us, like a portrait on a wall. That explanation is wrong. The moon spins. It spins at exactly the rate that keeps its back turned away from us, which is far stranger than not spinning at all. And nearly every other sentence people use to explain it is quietly wrong too. Picture the moon going round the earth. If it traveled the whole way without turning, a quarter of the way along it would show us its side, and halfway round its back. By the end of one lap, we'd have seen every part of it, the way a ball on a string shows you every face as you swing it round your head. So the fact that one side never comes past is the thing that needs explaining. It means the moon must be turning once in perfect step with each trip around us. Too fast and the far side swings into view. Too slow and it drifts in the other way. Only one exact rate hides the back completely, and somehow the moon found it. Hold on to that and to two other things everyone knows: a permanently dark side out in the cold, and the idea that we only ever see half. We're going to take all three apart. To see how the moon got locked, start with gravity, and one detail that's easy to miss. The Earth doesn't pull on all of the moon equally. The near side is closer, so it feels a slightly stronger tug than the far side. That difference stretches the moon very slightly along the line between the two worlds, a small bulge towards us, another away on the far side. It's the same effect that raises the tides in our own oceans, just working on solid rock. The young moon was hotter, softer, and far closer to Earth, so back then the stretch was much stronger. Now the part that does the work. Picture the early moon spinning fast, faster than it orbits, carrying that bulge round with it. If the rock responded instantly, the bulge would point straight at the Earth, and nothing would happen. But rock doesn't respond instantly. It lags. As the moon turns, the bulge is dragged a little past the line to the Earth before it can settle back, so it ends up slightly ahead of where the Earth is. And now the Earth has something off to one side to grab. It pulls back on that leading bulge at an angle, and an angled pull on a spinning body is a brake. Turn by turn, that drag bled the moon's spin away as faint heat inside the rock. Here's the part the tidy version gets wrong. The braking doesn't slow the moon to a dead stop. The moment the moon turns exactly as fast as it orbits, the bulge sits still relative to the Earth, and the angled pull vanishes. There's nothing left to brake. And if the spin ever fell below that, the whole thing runs in reverse. The bulge lags the other way. The Earth tugs it forwards, and the moon speeds back up. So one exact rate's the bottom of a valley. Spin faster and you're dragged down to it. Spin slower and you're pushed back up. The moon rolled in and settled there, turning once for every lap around us. That's tidal locking. Not a moon that was stopped, but one that came to rest. One last thing keeps that same face aimed at us. The moon is very slightly out of round, and its longer axis prefers to point at the Earth, like a weighted wheel settling to the same spot. So we know how it happened. When it happened, nobody knows. No rock on the moon is stamped with the date it locked, so everything comes from models, and they disagree wildly, from a few thousand years to tens of millions, depending on how fast and how close and how hot the moon began. That's not a margin of error. It's a sign the beginning is genuinely uncertain, even when the mechanism is clear. And the tidy story is about to lose two more pieces. Take the dark side. The phrase is older than the album, older than the space age, and it never meant a side the sun forgot. Sunlight falls on the moon just as it falls on the Earth, half lit at any moment, half in shadow. The catch is that the lit half and the hidden half aren't the same half. At full moon, the face we see is the sunlit one, which is why it looks full. 2 weeks later, at new moon, it flips. Our side goes dark, and the far side, the side we never see, is in broad daylight. So the far side is sunlit for half of every month, just like ours. It's not a dark side, it's a hidden side with ordinary days and nights we never get to watch. There is real permanent darkness up there, but only in a few deep polar craters the low sun never reaches, not a whole hemisphere. That leaves the last thing, that we only see half. We see more. Not at once, at any moment you're still looking at one face, but the moon doesn't hold perfectly still. Its orbit is a slight oval, so it speeds up when it's nearer and slows when it's further, while its spin stays steady. The two fall in and out of step, so the moon appears to rock gently from side to side, and a slight tilt lets it nod up and down too, so we peer a little way past every edge and turn. Over time, all that rocking hands us not half the moon, but about 59% of it, nearly a fifth of the far side, peeled into view a sliver at a time. So three things everyone knows, and all three bend. It turns, its hidden side has daylight, and we've been seeing more than half all along. For all of that, one question stayed open longest. What's actually over there? For thousands of years the answer was a blank, a whole half of a world no one had ever seen. Then, in 1959, a small Soviet craft called Luna 3 swung round the back of the moon and took the first photographs of the hidden side. They came back grainy and streaked, but they were enough for a real shock. The far side didn't look like the face we knew at all. The near side is covered in large, dark, smooth patches, old seas of hardened lava that early astronomers mistook for real oceans and named as seas. The far side had almost none. It was pale, rough, crowded edge to edge with craters, an older, more battered crust, without the lava floods that smoothed our side over, and that turned one mystery into a better one. The same moon, formed at the same time from the same stuff, had grown two completely different faces. We now know the near side crust is thinner, and the rock beneath it warmer, so molten rock could well up and flood our side, while the thicker, cooler far side kept it sealed in. Why the moon ended up so lopsided in the first place is still genuinely argued over. One idea blames a colossal ancient impact on the far side that stirred the whole interior. There's no settled answer. The hidden half turned out to be no copy of the near side at all, and why it's so different is a puzzle we've stood under for over 60 years and still haven't closed. What happened to our moon isn't a lunar oddity. It's one of the most ordinary things a small world can do. Every large moon in the solar system has done the same. Every big moon of Jupiter and Saturn keeps one face towards its planet. Pluto and its moon Charon go further still. They're locked to each other, each keeping one face permanently towards the other, turning together like a single spun dumbbell. And yet locking doesn't always mean one face forever. Mercury felt the sun's pull and settled not on one spin per orbit, but 3 spins for every 2, the same physics, come to rest somewhere stranger. So the rule was never that everything shows one face, it's that a close, long, patient pull reshapes how a world turns, and that reaches far beyond our own sky. Around other stars we're finding planets so close and they were almost certainly locked long ago, one face in permanent day, the other in permanent night, a thin band of dusk between. Whether worlds like that could hold life is one of the real open questions in the search right now. Our moon is just the nearest, plainest example of a force quietly arranging worlds we'll never reach. It was never sitting still up there. It was turning in perfect time, keeping its one secret, until we finally went round the back and looked.